Professor Jigar M. Pandya with my colleague Professor Brijesh S. Bhatt, representing Department of Computer Engineering, Faculty of Technology, D.D.University, Nadiad. We are going to discuss how we impart software engineering with the concept of problem-based learning, title In the Pursuit of Prospective Project. All engineers is going to be part of one or other project throughout their career. Faculties and engineering students, they are the stakeholders here, and then faculties have two different roles. They have to teach the students to make them ready for the future prospective project, and they also develop few projects by themselves from different sources. To bolster both faculties and students' voyage in the pursuit of prospective project, Department of Computer Engineering FOT DGU has a different insight, which is, let us make both stakeholders ready for prospective project from the sources of projects, which includes industry collaboration, teachers' research work, institutes' software requirement. We impart problem-solving based learning. Here, the thing is, we are developing project. We have a problem. We are finding a solution, getting ready the project. We are in the learning phase. Hence, it is problem-based learning. We are learning from the problem while solving it. We identified 6 major steps to apply software engineering. Step 1. Identify projects for which required technical competency aligns with curriculum. So from the source of projects, we have to identify projects whichever required technical competency which should align with the curriculum. Know that for universities, curriculum is the top priority. It has to be complete. So we cannot offer projects which do not align with curriculum. Step 2. Decide duration of project and various subject areas under which it can be offered. Step 3. Create the team. Once the project's duration and team are identified, now is the time to plan the task as per the student academic needs, which is step 4. Then step 5. Distribute tasks and decide milestones. Once the project is running, the monitoring progress and providing necessary support is the last step 6. In detail, let's talk about innovative practices, the approach or the steps 1, 2 and 3, where we identify the projects, duration and corresponding subjects. We create the team. We have the examples here. From the source industry collaboration, we have a project gimbal research project. We identify that it's a technically challenging task of 1 year and it requires a hardware and microcontroller knowledge. So we have good learning opportunity for students here who are interested in microcontroller. From the faculty research, a project titled Semantic Information Retrieval, we identify that it's suitable for final year full-time project because it requires knowledge of search engines, information retrieval theory, Java programming, and students should be able to learn and apply given the task. So we group students based on their skill set and interest and we create the team. Another example from the source department or institute software application, employee leave management system is a midterm efforts project. It requires knowledge of basic software engineering and web application development. So the pre-final year students, 2-3 students in a team should be able to achieve the same. Now then, we have identified the project's duration and subjects and created the team. The next is planning the task and milestone. Know that there will be generic tasks and milestones, and there will be specific tasks and milestones to the projects. The department has integrated projects at various courses level as part of generic planning and milestones. From first year, graduate students they work or extend some or other mini project under departmental subjects. For example, C programming, data structures. Pre-final year graduate students they carry out two major tasks. Now then, they have this knowledge of computer programming and data structures and object-oriented concepts. In the fifth sem, while they learn DBS, database system, and software engineering as a subject, they carry out project pre-work, amalgamated project pre-work. In the sixth sem, under the subject here system development practices and later summer internship, they do more project work. Know that 7th sem we have placement, hence there is no project offered. In the final year, in the 8th sem, last sem, students perform tasks as full-time project internship at industries as well at department level. And postgraduate students, they perform survey and research as part of thesis, dissertation. So then the projects are running, the only thing is left to monitor and support. Whenever the team is stuck, they need support, hint, guidance to move on. The role of the teacher here is not the traditional role. Teacher does not teach the content, no. Teacher rather acts as a mentor which provides necessary knowledge and guidance. Idea is let students make hand dirty and learn lessons hard way. When students face challenges, faculty provides necessary technical support to overcome it. Let students brainstorm and find solution. Faculty provide knowledge incrementally. Talk about task 2, which is usually more difficult only once the task 1 is finished. So then we learned about the problem-based learning, measure 6 steps and their examples. Now is the time to see the proof. Let's see faculty is in action at Computer Engineering Department FOT DDU. There are faculties exemplary live development, ongoing and past. From the source industry collaboration, a gimbal research project, a SNOT application identification project. From the source faculty research, semantic information retrieval project. At institute level, institute software requirement, e-government's head, student and university portal. Student can see their results, hall ticket. University has a portal to maintain all internal information. It also includes customized Moodle, which is an online learning resource for students from certain batch, certain subject offered. They only see their subject, not all. They only follow their quizzes, not all. It's a customized Moodle at DDU. Thanks Moodle or for the same. Department software, see faculty portal. We have subject preferences, leave, document archive, library, local library. They are all managed by the faculty portal at C department. So this is faculties in action. Few captures on the top, institute software, Moodle. On the left, faculty portal, which is a department software. On the right, industry collaboration is decision tree log file pertaining to the SNOT application. Let's say students in action. Students themselves have exemplary live development. Web and mobile based information sharing for Fellowship, which is an annual technical and cultural festival. Every year during this festival, students themselves develop the site and the app. There is a mobile app for viewing results, which is a wrapper on top of the university's site data by students. A web-based university newsletter, a web-based faculty feedback by students application, which is one of the ISO mandate. National level e-yantr robot design and software development project competition. D.D.University proudly won for 3 consecutive years, 2012, 13 and 14 at IIT Bombay. So see, there are rich number of activities by students with respect to software engineering projects. Few captures, top the newsletter site, on the left the results on the go app, on the right the technocultural festival Android based app. So as far as the content is concerned, software engineering has many things to do with contents. Documentation, all the phases. Demonstration, the 6 SEM BTech students under the system design development practices, they develop the project and they demonstrate to the internal guide and the external examiner, telling a story of application uses with fingertips. 8th SEM student, industrial training, they just present, they talk about technologies and crucial logic behind the scene. The distribution, of course, all students try to package and share, for example, using GitHub, Play Store, etc. So the documentation, let's just see the embedded document here. This is one of the report by 6 SEM students team, and if you see that they follow the complete STLC or agile methodology like thing. They have the software requirement specification, they have design, they have implementation, they have testing, layouts, and then in the miscellaneous section, see that they learned lot different things like GitHub, subversion, XML parsing, JRules, etc. So they explore more and more. That is what the point here. So in the 6 SEM, there were around 145 students and around 80 teams who did different projects. Headings are shown here. It includes mobile apps, e-commerce site, research-based project, encryption-based project, RSS feeds, management softwares, etc. In the 8th SEM, again, there are like around 80 groups from around 60 industries, and you see that they also have worked on various project titles. To see the distribution, DDU results available on Google Play Store, available on Microsoft App Store, and one of the example project source on Git. So there was software engineering contents. Faculties provide and guide a lot many contents to reach to the destination for the project. This is another screenshot which shows that implementation, test case design, etc. is carried out by even the 8th semester students. We created a Google form and then we collected feedback. 70 around 64 percentage they agree, and around 28 percentage they strongly agree. In total, around 90 percentage of students agree that these projects initiatives are a lot helping both to the students and to the faculties. This was current student, former student, industrialist, all 33 responses. They also agree that documentation skill, technical skills, and teamwork, they are the 3 major points which have been noticed for the improvement. There are few appreciation. Faculty is very supportive. Practical knowledge imparted to students is far better than other colleges. Teaching is already nice and it is improved by visualizing boring theories this way. Conclusion, With the attentive PBL steps as mentioned, we see the positive difference in students and faculty's project industry readiness, effectiveness attained with different skills. Overall, software engineering turned now a lot interesting and challenging. Students learned the importance of each stage the hard way. Students' resume and interview appearance have better impact of the product they build. Thus, at Computer Engineering Department, FOT Nadiad, we just do not teach software engineering, but we actually work to impart software engineering. Thank you very much. These are going to be references, and then